Okay, you guys, we are looking at problem number 6 on our review. So we're going to calculate the enthalpy of reaction for the following reaction. So we're going to use our thermodynamic quantities table to use the enthalpy of formation values at a standard temperature and pressure. So one thing that we need to remember when we're doing that, so we're going to start by looking up those values, is that an element in its elemental form, so O2 is the elemental form of oxygen, is going to have an enthalpy of formation of 0. It's not forming, it already is oxygen. So that makes our job a little bit easier. Once we have those values, we're going to set up our reaction. We're going to use the equation that the enthalpy of the reaction is equal to the enthalpy of the products minus the enthalpy of the reactants. So we're going to start with products, and we're going to look at 4 of the nitrogen monoxide gas plus 6 of liquid water. Remember, enthalpy values depend on the state of matter that we're in, so make sure you're using the liquid value, that negative 285.83. And then we're going to subtract out the reactant. So we've got 4 of the NH3 gases plus 5 of oxygen. And oxygen is an element, so that's going to be a value of 0. Now be careful with your math, you guys. On the homework and on the quiz, this is where people are starting to make mistakes. So I would first find the sum of my products and then the sum of my reactants and then do my math. So when you subtract a negative value, remember it's like you're adding that value. So what I ended up with was negative 1,168.74 kilojoules. This is going to be a negative heat value, which means that this is an exothermic reaction. So as this happens, heat is given off.